Without much further ado, you're up. Good morning, everybody. Container Hacker to DevOps. Let's start. We'll discuss the design of containers, the ways to break into them, and why we, as infrastructure security people, have to check and double-check them before committing to prod. So, the most contained security presentation and the most secure container presentation, I'm guessing. I'm a security lead for Kubernetes at MTS. It's division, Verb Services. We're developing a new cloud service that will be released soon. So you'll be able to get a hands-on with it, just in a couple of days, actually. I'm a DevOps engineer, or I used to be, but it stays with you for life. It's a mindset that you carry through life. I'm now also an InfoSec expert, and I also teach at universities. ITMO, VGU, that would be in Voronezh and St. Petersburg, and I host CDX. Just recently we had an event for school children and college students. It's a lot of fun, prizes are nice, so if you have some up-and-coming young professionals or you yourself as a student, come to us, to Voronezh, to participate in our CDF. First, we'll address the anatomy of containerization, how it's designed, what it does, why it does that, a bit of a background for you to ease into the substantive part of the presentation. Next, we'll be speaking about the main ways to break out of a container and why you have to mind your T's in certain configurations. In closing, we'll apply this to Kubernetes, how this works there, what configs need to be by default and always by default, and where you have to be very specific. After the presentation, I think you'll see why it's like this. Let's start with the anatomy of containerization. You've seen this a million times. Everybody is aware. Just one thing to keep in mind is that there is a shared core for all containers. OS core is shared by containers, unlike VMs. A container still constitutes virtualization or isolation, and it's enabled by the tools that are available in the OS core. Why is this important? Let's assume we have a company. There is a nice developer. Here he is, or she is in the picture. They develop great features. Then engineers come in. They release it to production. They do everything for it to compile faster, to work efficiently. They optimize it for different situations and use cases, even undocumented. It's all great, but then you have security review, and it all goes down the drain. It all has to be redone. You're nice and dandy, but you just can't do these things. And I'm speaking about business services as well as infrastructure services. And in infrastructure, you have networks, hardware, file management, tapping different devices, add nodes. In this latter case, you have to provide as few privileges as possible or deviate from some standards. So we'll focus on what we look at when we review containers. But how do you qualify a container? There is a set of mechanisms that you've heard about, most likely, and others maybe not. So here is a crash course on containers. First, you have Linux capabilities. Don't get anxious. It's just a list for now, then we'll make a deep dive. Linux namespace, C groups, AppArmor, C Linux, and seccomp.
Это основные механизмы, которые делают контейнер.
These are the main things that qualify a container.
Что касается capabilities, то
Let's give it a bit more thought. Capabilities. What that is a way to segregate a super user's root privileges into small bits and assign those privileges to a process. They've been out for a long time, kernel 2.2, and they're an attribute to a flow. We can look them up in proc, and they're all included in capabilities.
Периодически по ходу второй части будет возникать утилиты для
We'll get back to cap.sh, the utility to look up capabilities.
Они будут описываться
In the system, they are described as bit masks, and for human reading, we'll be using cap.sh. Other utilities are getCap and setCap. You either set them or look the capabilities that are set. And there are different capability sets: permitted, inheritable, effective, ambient. These are to make authorization of super users for certain tasks easier, to not use setgit, and bounding. They used to be restrictive in terms of available or permitted capabilities, but now it's part of KSV process. And then here is cap.sh. That's our current capabilities that are installed in the system and that are operational, that are running. That's what we need to look at in the container before we go on. Then we have Linux namespaces, abstractions on top of the OS. The ID UTC network, host names, for example, mounts users. You can hand over a process to a new namespace, and some things that are seen in the parent process cannot be seen from there, unlike the other way around. So that's pretty much like parents and their kids. Kids live on their own, think that nothing of what they're doing is seen by the parents, but parents have a look over them. Then PID namespace is the parent namespace isolates a tree of processes. The parent process sees everything, unlike the derivative processes. So the numeration is different. Then we have mount namespace. It allows chroot, a great thing that you've heard about, I'm guessing. You change your root directory, and the process will be confined to this root directory. Everything above will not be available. That's the second thing that qualifies a container. By default, we cannot see what's going on the host if we did not pre-mount anything. Then there is network NS. It isolates the entire stack, IPv4 and 6, routing tables, firewall rules, procnet, and network interfaces and devices, as well as the communications between them. So the container would only see the packages that it receives, but it doesn't see what's going on the host machine, unless you let it or forget to configure something. Cgroups is the most popular namespace, I'm guessing. It limits processor time and RAM. It merits a separate presentation. Their behaviors are diverse and interesting, where you have OM killer, how the processing time is sliced, but it's not for today. Just letting you know that this is the mechanism for the container to limit the processor time that it can get at and the memory that it can access to. If it asks for more, it will be killed in case of ROM. Then there is mandated access. It can be CLinux or AppArmor. Let's think of AppArmor as a file where there is a profile for the app, what it can and cannot do, what files it can handle and not, what privileges it has. So the container will not be access things that it hasn't been expressly allowed to. Under the hood, this is enabled by LSM, Linux Security Modules. Again, it's supported at the kernel level. If you try to do something that's forbidden or prohibited, the kernel will send a hook notifying this, and you'll be prevented from executing that action. And then we have CCON. It limits the system calls that the container can execute. System calls are basically the main thing in an OS for user space to interface with kernel space, and we can remove actions that can be a vulnerability or what our app just doesn't need to do. If you're interested in eBPF or LSM, you can review your the other slides at your convenience. It was from my presentation focused on these two topics, so pretty hardcore in a way, where I was laying out ways to bypass those checks. So at your convenience, the slides are made available. But there are ways to ensure secure airtight isolation, but not everybody does this. We have this sandbox, which is a container. Let's look at ways to break out of it. There is a repository of examples. I recommend you review this, you try this at home, this you try at home. All attacks from today are detailed there and analyzed. It has code bits, split, descriptions, demos. So everything I will tell you today is available for you through this code to stand and run at home. Breaking out of the container, manning the middle attacks. Very curious to give it a go. Let's look at the high-level view of different ways to break out of a container. Not all containers can be broken this way. If it were possible, containers would make no use. Why would you need isolation that doesn't isolate things? But there are containers that are secure indeed. But in production, there is a whole bunch of containers that can be broken like this potentially. The first attack is to mount a host file system. The minimum requirement for this is for the process that the container runs on and the capability called sysadmin. Most of attacks require specific set of capabilities or isolation being switched off for a namespace. And then we'll have C groups as well. Let's talk sysadmin first. It's a very interesting capability. Do keep this in mind, commit this to memory, and if you see this, it should trigger your big way. It's a very relatively or very old capability. It's quite comprehensive. It's a capability that basically has root privileges. It can do very many things. If you go to man, it lists how it enables BPF, how it can mount and unmount things.
распиливают, и относительно недавно ее распилили, вот вытащили кап BPF, которая позволяет программы
has
самостоятельно
been in development to be broken up into smaller capabilities, but
куда приходят
it's very often that in case of a super user,
до недавнего времени приходили, искали там
you would go online mostly until recently to Stack Overflow. So the difference between junior and senior expert is that juniors copy their code from the LP and seniors go into comments. So if there is a privilege lacking for a sys app, developers do some minor thing with this blanket capability. And it means that in production there is a huge bunch of containers that has pretty unhinged privileges that a container would never need. Then you can use a pre-mounted Docker socket. It's called Docker Escape, but it applies to most container type runtimes. Container ATE, Creo, that so Docker Escape is
этот вариант используется в докер-сокете. Почему? Потому что у нас все еще есть раннеры.
Is what it's called. This is used in Docker Socket because they have runners for builds and deploys. You add a socket to a dynamic runner and you are already capable of managing a Docker on a host. That's very convenient, but there is a number of vulnerabilities in the runners that you need to keep in mind. Then shellcode injection can be done versus ptrace. We'll be trying to deliver shellcode in debugging. Sometimes people just leave it hanging in production, but this is just for debugging, so you should never have it there. Kernel module injection, a less frequent one, but if your app engages models of the kernel and it's been containerized, or if you have this capability on, it's an attack that you're exposed to. Sysmodule enables import and export of new kernel models. Well, it's in the name. Reading secrets from the host through DAC read search. These capabilities can be in place, and then sysadmins come in and reprimand you. It can be then changed to DAC read search. Override, slightly better, but still vulnerable. And then there is the last one. It's not outdated yet, but mostly notify on release. That's in C groups. That's if you run C groups version 1. There is one feature of the scripting part that we'll look at. So, mounting a host file system. The most basic attack that there is, and you're probably well aware of it. You have to have the container in cap sysadmin. You have to disable AppArmor, otherwise it won't work. So you have sysadmin capability, you disable AppArmor. Both Docker and Kubernetes enable this by default, but some people enable AppArmor unconfined to get full creative license, but then you don't switch it off and you get what you get. My demos are in the slides, but you can do this at home at your convenience. You run capabilities, you install all, you do sysadmin, you disable AppArmor, and you mount dev. So out of the container, you can execute this operation and see that it all works. This can be done from within the container. Let's say we have access to Docker. The user is restricted in the main system, but we can mount the directories that are inaccessible. You run a container where you have root, but then UIDs will be the same and you just swap them. You'll be able to access the directories that you were restricted from. The same attack works in Kubernetes. If you have privileges to set up containers, you can execute code there where you'd be able to mount the entire file system of the node that this code runs. You'll be able to steal secrets and worker nodes. That's not very dramatic, but if you go from your node to control plane, you'd be able to manage the entire Kubernetes system there, and you'd be having cluster admin privileges. So it requires monitoring to be detected, and it's really hard to respond. If it's open, then there is no monitoring, probably. Then there is Docker group. If the user is in the Docker group, it can be done. It's specific to Docker and Kubernetes. This will not fly, but it's something to be mentioned. If the user is in this group, they'd be able to execute all commands, even if they were not given the privileges. Then there is set UID and set GUID. If you have these bits in your Docker, the Docker will run with super user privileges. The second option is remounting a Docker socket. There are some caveats here. Not as many, but you have to keep it all in mind. Remounted Docker socket container, that's usually done in Docker and Docker. You mount a socket, you do all builds through host, but that then mean that from this container you'll be able to manage host Docker. So you can make it more secure by applying these. You set the flag, privileged. In Kubernetes and container runtime, this flag is a bit different. Your app will not have app armor. So it'll have all capabilities. Just one flag that destroys all of your security. These are the things that you shouldn't do. In sys apps, people often do privilege true. Everything gets working and people forget about it. Here is a demo. We have a Docker socket. It means that you can stand a new container on the host, cannot prevent it from this, and then you can chroot into host. Again, you have access to the entire file system of the host operating out of the container. Docker socket is open to all users. We are not part of the Docker group, we're just a user in the system, but we can set up containers with Docker sockets. That's what I've just demonstrated. The first attack is shellcode and how you inject it through ptrace. That's for debugging. It shouldn't be in production, but when manifests are copied over, it gets overlooked, and this capability can end up in production. CSP trace is dangerous. It also requires PIDNS from the host to be shared with the container. That's for the container to see the process tree of the host. So the exploit and the shellcode are out there in the repository. We'll briefly look at some highlights. That's assembler shellcode. Nothing particularly interesting, except that it opens the socket and it calls binbash at port 5600. That's how it's encoded, and then you inject it with the start address, and then it will be called. And here is the shell script that assembles the injector.
Просто как пример такого приложения.
You run a server, you look up PID,
Инжектим в него shellcode. Вуаля!
and you inject your shellcode.
Возможность запустить веб-сервер
So
фактически.
that allows you to run a web server out of the container.
И делать уже дальше, что хотим.
You can
Мы надкатимся к серверу.
connect to the host and do anything. You use Netcat and do your research. That's what you get from debugging. Let's look at kernel module
В данном случае мы можем просто
integration.
взять с сайтика готовый реверс shell.
It's available online. You have this reverse shell, for example.
И дальше
You make it
и сработает все то же
a
самое.
kernel module and you insmode it.
Реверс shell и получили доступ к
The rest is the same. You inject reverse shell, you get access to the terminal command line. Just because you were able to output kernel modules from the container.
На хосте.
Tag read research, tag read override gives you access to files on the host machine. You have this function open by handle add. As this call, we'll be reading GC shadow and then we'll be brute forcing the password as well.
Вот пример.
Here is how this works. That's a function that I called out. If you have capabilities for DAG research and read override, you'd be able to go through the files on the host. That is through open by handle, and we'll be able to extract data from there. It's not as likely as this.
То любой переборщик паролей, стандартный Джон Риппер, справится на ура. И как показывает
As this, but then you can use any run-of-the-mill brute forcer for passwords, and the host passwords are pretty simple usually. So it happens pretty often. We have a dev stand, there are VMs with Dockers, there are containers maybe. Nobody is concerned about it that much. But then you get access to the container, you get a hash of passwords, you see that it's one of the easier default passwords, and then it's reused across the infrastructure, which will be a big problem.
Sometimes there is no isolation. The next point is C group release agent. Not the very best thing today, but nevertheless, if you have C groups version 1, low probability, but at legacy systems you might have it. Those C groups have such thing as notify release, and script release agent is executed in the end. What you put in will be called. This is an example of the payload. Let's look at it step by step. Actually, we run a container, put ourselves there, write the script into the release agent, and if we have access to C group, what was written in the C group will be executed. So step by step, but let's skip it, because actually we just write our script into the release agent through the variables. So you put it in the release agent and execute, and it will run. In version 2 of C groups, it doesn't work. But if you have C groups version 1, pay attention to it. And this option can be switched off. If you put 0 in the configuration of C group, it will not work. And finally, ARP attacks. It doesn't operate everywhere. If you have Docker hosts, it will work. If you have Kubernetes with an old CNI, simple one, it may work. I saw installation of K3S in production, simple cube, flannel inside, and that's all. Such attack will work in that place. Is ARP attack. ARP is Address Resolution Protocol between level 2 and level 3. It helps us to use IP address to get MAC address of the host. It's one of the most important protocols in Ethernet, one of the basic ones. And there is ARP spoofing, man-in-the-middle attack, which helps us to respond faster than the host. And this protocol is such that if we respond earlier, our response will be valid, our address will be entered in the table, and all the calls will go not to the host, but to us. We can resend it to the destination host, and we'll become a man in the middle. And we cannot be detected. Even in the most advanced systems, we may get such systems where it works. Let's have a look. In repository, we have a script which helps us to launch a demo stand. And now let us have a look. Let's see how it works. We have server 1, server 2, and a hacker who uses computer 1, and we have a router or a switch. It doesn't matter. For example, server 1 wants to talk to server 2 and sends an ARP call. So return your MAC address. The server responds to server 1 and everything's all right. However, if the hacker is going to send his MAC address, if server 1 gets his MAC address earlier, so it will believe that 140 will be the destination address and all the traffic will go there. It works very well in the container environments because we have a root namespace. Also, we have Ethernet 0 for a network card, and all our containers are in their own namespaces with virtual Ethernet, which is connected to the bridge, Flannel, Docker, everything is there. And if you send ARP attack, it will work in this environment. For that vulnerability to work, you need capnet raw. And it works by default. This capability enables you to catch traffic in the container, analyze, change packets, and do anything you want. So, we can replace packets and do a lot of malicious things, and no one will detect you, no one will see you. Let's see how it works. To launch it, we have to plan the scripts, launch the scripts, and then launch the ARP spoof script. And the picture will look like this. We have a customer, a hacker starts responding, and our customer will get the traffic from the hacker, although the destination was different to container 3, but traffic will not reach the destination. And the last thing, how can you move all that to Kubernetes? Because we often use Kubernetes and we configure it there, but we can do all that because it is specific for container runtime. Docker and Kubernetes have the same container ID. If you don't change, you can choose a different runtime, but fundamentally it's the same and universal. It is applicable to any container environment. First of all, you have to remember that Kubernetes by default uses the standard set of capabilities, caption, duck override, we mentioned it before, and NetBeans service, NetRaw. We also mentioned it. Not all of them are vulnerable, but some of them are. When you deploy a new application, you must drop all capabilities. For business applications, it's universal. It should be done always. They need nothing but go to database or something else. If it's a system application, then you have to go to developers, create profiles. CComp enables you in the audit mode to audit all system calls of the application. What kind of system application do you use? If developers doesn't know it, you launch the application with CComp profile, open the monitoring mode, and see what kind of system calls are there. Then you can use that information here and it will work. And you will know what kind of system calls you really want. You can minimize the list.
User namespace.
Then user namespace. It's a recent option in Kubernetes. Remember that by default, we have to make host user false. Root container and root host should be different. And security context recommendation. Privilege is always off, should be a privilege escalation also off, so that even if a hacker will be able to launch the containers, it should have privileges higher than the host ones. Add only what you need. CComp profile should be visible. Opammer is also good. Read-only root file system. No write. And run as on root, by all means. Sudo user 1000, group 1000. Of course, it's configuration. There are other practices. Simple images, the number of tools in the container, elimination of excessive tooling. It all works. If you go to off-stack, you will see it. It's a standard list of configuration that works for all applications, and you have to use it in your development teams as a universal set. As far as deviations are concerned, they are to be discussed separately. We have our hubs where you can read everything, how we develop in the cloud. You can look at our track and vote for my presentation. I think you will like it. Your feedback will help us make our presentations better. Thank you, thank you. Now it's time for your questions. Questions should be asked through the microphone. Hi, Leo, I'm Alexander. Thank you for an excellent presentation. You told us that you have to use profiles. If we understand that we need a dangerous privilege, what are the guides, the recommendations, how to provide such privileges if we need them? Yes, that's quite important. Development of large systems is related to host operations. To begin with, you have to be in touch with the developer team, with people who support a certain service, talk to them, explain how it works, what you can do. Very often there is a big component of the system which does a lot of things and something dangerous. And that dangerous thing should be moved away into a smaller component to work with it individually. Second, if some components and capabilities cannot be deleted, then look at the infrastructure wider. Where is the cluster? How you can get to that cluster? Very often there are some managed networks, and we can change the configuration. You can think how to get to this cluster, limit the number of customers, so reduce the attack surface. It's impossible to eliminate everything, but you can make the hacker's work much more difficult. He wouldn't have the time for his attack.
Слышно? Лев, привет. Спасибо большое за доклад, очень понравился.
Hi, I liked your presentation very much. Recently, I saw an interesting situation.
RCE, blind RCE.
We have RCE
Docker container с BusyBox.
in Docker container with EasyBox. BusyBox without netcat in get and sh. Can we escape in this situation? Because I couldn't escape.
Тут в данном случае, да, зависит отчасти от инструмента.
Yes, it depends on the tools that are available.
Какие-то они доступны.
Some of them are available, but others are not. If, for example, the intruder, well, if it's RCE in POP-C, you can attach a side container. You have to look at the specific situation, at the environment. Maybe from the container, if you cannot deliver the packet with destroyed image, you cannot do anything. You get RCA on the root. Well, this is not the worst situation, anyway. You can rebuild it with a different image. There are different options, but we have to look at the specific situation. Thank you. I remember what IPMI was there, and I downloaded something else instead. Well, any more questions, please? No questions? Then I have a question. Leo, please tell me, did you use AI? Did you use AI? Have you got such an experience? Did you automate? Did you teach AI? I don't want to be an old and retrograde person. AI generates manifestos, rules, lightweight rules. Of course, they have to be validated and checked, but some simple things, well-known things which are available in the networks can be done, and you can use it in your work. But that's rather interesting. If you generate something through AI, you can reduce your workload anyway. Well, then let us thank the speaker very much, and the speaker should choose the best question. Well, it's about RCA. Please come here and get the prize. And I remind you that it's important for you and for the speakers to get your feedback.